All right, so let's suppose, now this is section 1.7, and we're looking at absolute value inequalities. Now, the only one you're going to have in your test is the one that's going to look like this. So you're going to have absolute value of 2x minus 5 is less than, let's say, 6. I'm making this up. All right, absolute value of 2x minus 5 is less than 6. Now, remember, that's not a linear inequality. So don't just drop the absolute value bar and solve 2x minus 5 is less than 6. That's incorrect. It's an absolute value inequality. So based on the notes that I asked you to look at in the video, what do you think? How are you going to rewrite this?
As 2x minus 5 is less than 6, but it's also less or greater than negative 6. Right?
Okay, so you're going to write as a compound statement. So where you're going to have two inequalities in a statement. So basically, you're going to say 2x minus 5 is less than 6. All right, now that's part of it. Now, that would, remember I said don't write like this and solve that. That would be your mistake. Not only is 2x minus 5 less than 6, but at the same time, it's greater than what? Negative 6. So you're supposed to look like this. All right, so 2x minus 5 is less than 6, and at the same time, it's bigger than negative 6. So that's how you're going to rewrite this. So you're going to rewrite an absolute value less than, and that was the only one we talked about was the less than, in a compound statement with two inequality symbols, and they're pointing in the same direction. I made that clear as well. Don't make one greater than the other and less than. That's incorrect, mathematically incorrect. So you see that symbol is less than? These have to be what kind of symbols? Less than. If this was less than or equal to, these have to be what? Less than or equal to. All right? And then the idea is to get what in the middle? Yeah. Now this part here, this part that I'm showing you right here, this part right here, that was Math 98. Okay, that was Math 98. Actually, I think it's Math 99. I can't remember which one, but I remember doing this. So basically, now this part isn't. That's the new part, but this part you did. So remember, you just got the variable by itself. So if this were just a linear inequality, what would be the next step? Add 5 to both sides, right? But there are how many parts here? 3. You're going to say plus 5, plus 5, plus 5. And then negative 6 plus 5 is negative 1 is less than, combine like terms, what are you left with here? Is less than 11. All right. Now you haven't, remember you're trying to solve this inequality, so you're trying to find the solutions that would make this true. So we're almost there. So I know that 2 times my solution has to be less than 11 and greater than negative 1. But what is my solution? What do they have to be? What do I need to do next? Divide by 2. So I'm trying to get x in the middle, right? So, and then you simplify if you can. I cannot simplify here. So you're going to say negative 1/2 is less than x is less than 11 halves. All right, so all of my solutions between what two numbers? No. All my solutions between what two numbers? Negative 1/2 and 11 halves. Okay? All right, then you'll be asked to graph the solution set. And you can check and see if this is correct. Give me a number that's between negative 1/2 and 11 halves. Now remember, 11 halves is what number? 5.5 or 5.5. And obviously this is negative 0.5. So give me a number that's in here. 2. All right, let's check it. You all go back to the original. What's 2 times 2?
4.
What's 4 minus 5?
1.
What's the absolute value of negative 1? Is 1 less than 6? Yes. Give me a number that's not in here. 7. Okay. 2 times 7. 14 minus 5. Absolute value of 9. Is 9 less than 6? No. All right, so those are the only solutions. And how many solutions are in here? No, that's not the word I want to use. What? An infinite number of them. Okay, there's an infinite number of solutions. That's why you can't list them. You have to graph them. So in the number line, and when you picked up the worksheets, you'll notice that I did put a number line on those. On the number line, let's say this is negative 1, 0, 1, 2, 3, 4, 5, and 6. That's 6 here. All right, now there's no equal sign. So am I going to use brackets or parentheses? Parentheses. When do I use brackets? When there's an equal sign. So this was less than or equal to. So at -1/2, what will I use? Parentheses or brackets? All right, now you got to locate where -1/2 is. -1/2 is between -1 and 0, right in the middle, correct? And I'm going to use parentheses to kind of estimate where it is. Let's say it's here. So notice that's parentheses. And then 11/2 is which way? Yeah, between 5 and 6, right in the middle. All right. And so I'm saying that all my solutions are between these two numbers. So what should I do then? Shade it in. No arrows. You're just shading in. And so there's your graph. Now from that graph, you could tell me the interval notation. So just read it from the graph. What do I write first? Parentheses. What is it? -1/2, comma, 11/2 with parentheses. And there's your solution written as interval notation. These are your solutions written as a graph, and these are your solutions written as an inequality notation. This is inequality notation. Okay. All right. Now, so let's write this as number 1. Okay, number 2, suppose you had this. You have the absolute value of 5x plus 1 plus 3 is less than or equal to, let's say, 6. Again, I'm making this up. What is it that you're supposed to do first?
We want to subtract 3.
Right. You have to get the absolute value expression by itself. So you have to subtract 3 from both sides first. If you don't, you're going to get some kind of error. Your solutions won't be correct. So you subtract 3 first. You got to get the absolute value expression by itself. And so 3 and a -3 is 0. You're left with what on this side? Oh, no, on this side. Right. It's less than or equal to 3. So you left 3 on this side. All right. Now, it's by itself. It's a less than inequality, less than or equal to. So I'm going to rewrite this. You got to rewrite it now. You're going to rewrite it without the absolute value bar. So how will I do that?
-3 is less than or equal to 5x plus 1 is greater than.
No, not greater than. Less than or equal to 3. All right. So she just went ahead and she just read it from left to right. So -3 is going to be less than or equal to 5x plus 1 is less than or equal to 3. Now, some of you may say this. Well, 5x plus 1 has to be less than or equal to 3, right? And at the same time, it has to be what? Greater than a -3. Okay, what's the next step? No, not add 1. Subtract 1. So subtract 1. Adding 1 is mathematically correct. I mean, there's nothing wrong with adding 1 to all parts. Because mathematically, what you do to one side, you do to the other, but it's not going to help. You have to do what? Subtract 1. That's what's going to help you to get the variable by itself. You're going to do it from all 3 parts. Notice 1 time, 1 time, 1 time. Combine like terms, -3 and -1. Less than or equal to? Less than or equal to? 2. All right. And then finally, the last step. Divide all parts by 5. So I'm going to get -4/5 is less than or equal to x. That's 1. It's less than or equal to 2/5. All right. And so all your solutions to this inequality will be between -4/5 and 2/5, including those two numbers. And you can check 2/5. Let's just check 2/5. Now listen to the words. I'm checking 2/5. What's 5 times 2/5? 2. 2 plus 1 is 3. Absolute value of 3 is 3 plus 3 is 6. Is 6 less than or equal to 6? Yes, it's which one? Equal to. Okay. All right. And then you could do the same thing with -4/5. Now listen again to this. I'm not writing anything down, so just listen. 5 times a -4/5. What do you think that is? Yeah, so remember I'm saying this. 5 times a negative 4/5. Remember in previous courses you divide these out? What's left? Negative 4. Negative 4 plus 1 is negative 3. Absolute value of negative 3 is? 3 plus 3 is 6, less than or equal to 6. Yes. All right. Now on the graph, you're going to have to estimate where these are. So let's say this is negative 1, this is 0, and this is 1. That's about all I need. Okay, negative 4/5 is like negative, use your calculator to write as a decimal. That's negative 0.8. So it's close to negative 1, right? And I'm going to use brackets or parentheses. Okay, pointing to the right. Something. So it's located somewhere around here. 2/5 is 0.4. So it's close to a half, correct? So let's say it's about here. Because you're estimating where these are. And so what do I do next? Shade it in. So there's your graph. Interval notation. What's the answer? Yeah, and that's it. That's all you do. Okay? All right. So that's less than? That's less than. All right, so there is one in your test with an absolute value less than. So you just rewrite it as a compound statement. All right, now let's talk about greater than. Now greater than is different. Greater than is different. So now if you looked at the video when we on page 13 of the video, you'll notice that when we first did this, we didn't do this right away. We looked at the absolute value of x is less than 2. If you remember that from the video. So we can do the same thing with greater than. So let's look at greater than. So I'm just put this as number 3. Okay, let's do 2. Greater than 2. Okay, that's a 2. All right, so basically, if you having trouble on a test, and you may, if you're having trouble in the test, not test 1 but test 2, because on test 1 it's just this kind. On test 2 will be this kind and this kind, and on your final as well. So you may at that point get a little confused. Well, if it's less than, I can't remember what's the next step. If it's greater than, I can't remember the next step. Well, always remember this one. So here's how you think about this. On the number line, if this is 0 here, let's say, think about the absolute value of which of these real numbers will be greater than 2. So give me some numbers. 4, okay, 4, I'll agree, 4 is a solution. So on 4, I'm going to put a dot indicating that's a solution. So let's check it. The absolute value of 4 is what? Is 4 bigger than 2? Yes. What else? Let's just deal with the positives for right now, and you'll see why. 3, okay, 3 works. The absolute value of 3 is 3. 3 is bigger than 2. What? 2.5 works. Okay. The absolute value of 2.5 is 2.5. 2.5 is bigger than 2. What do you think is going to be the smallest one? 2. No, not 1. Because the absolute value of 1 is 1. 1 is not bigger than 2. So what do you think is going to be the smallest positive number you can use? 2. With what, though? No. Yeah, I agree. 2.1 parentheses is what I want you to say. Because I say, what's the smallest number? And you said 2. That's true to a certain extent, but not quite, because what's the absolute value of 2? 2. Is 2 bigger than 2? No. So that's why we use what? Parentheses. So on 2, I'm going to put parentheses. And y'all agree it's all of these numbers over here? So I'm going to shade it in and use a what? No. Arrow. Arrow. Because is 500 a solution? Is 1,000 a solution? Is 1,000,000 a solution? So it's from 2 all the way to what? But not including 2. So I found one part of my solution set. All right, let's talk about the negatives. Give me some numbers you think may work. Negative 3. Okay, that's here. That will work. The absolute value of negative 3 is 3. 3 is bigger than 2. What else?
Negative 4.
-4. So in fact, I mean, you could check it. The absolute value negative 4 is 4. Is 4 bigger than 2? In fact, everything between here, right? And all the way down to what do you think? Not 2. Negative 2. Negative 2.5 works, correct? So let's say negative 2.5 is here. What's the absolute value of negative 2.5? Is 2.5 bigger than 2? In fact, all the way down to what? Negative 2. Although I can't use it, because what's the absolute value of negative 2? Is 2 bigger than 2?
No.
No. So be parentheses. Now be careful. Don't put your parentheses pointing this way. All right. You got to put your parentheses pointing which way? Pointing to the left. Opening to the left, right? And it'll be all of these with a what? Arrow. Okay. So notice in the previous one, less than, your solutions were bounded between. Notice there were no arrows, right? In the previous one, less than, do you see any arrows here? No, they were bounded from one number to another. Greater than, they're not bounded. They're two separate inequalities. This one and what? That one. All right, so greater than, for the most part, is going to look like this. Two separate graphs with arrows. All right, now here's how you're going to write it. Okay, so in terms of inequality notation, let's look at this one first. This says that all my x's have to be what? Greater than 2. So this says x is greater than 2. Right? This says that all my x's have to be what? Less than negative 2. That's what that says. All right. Now, going back over here, remember when we rewrote this, we rewrote this expression right here, the inside expression, without the absolute value bars, right? Is what we said first. We're going to say 2x minus 5 is less than what? 6. That's what you see here without the absolute value bars. At the same time, though, it has to be bigger than what?
Negative 6.
All right, so that's why you have this bounded set here. Over here, though, remember what I did to go from here to this part, just rewrote. Basically, I rewrote what I saw, right? Okay. Well, rewrite what you see without the absolute value bars. What do you see? X is greater than 2. So what you're going to do is, when you rewrite it, when you go from this step to how you're going to, first of all, set it up, you're going to say x is bigger than what? 2, which is what this is. But then you're going to say, or my solutions can come from which set? So you're going to say x is, and all you do is reverse these. So x is what? Less than, and take the opposite. Remember when you divide by -1, you reversed? So think of it that way. So you're going to say x is less than what? -2. So that's all you do.
You don't write them together?
No, they're not together. What do you mean by together? How would you?
Well, I mean, I was going to say like -2 is like greater than x, which is less than 2. Like
No. You when you write it as a compound statement, that's an and statement. So when you write it like this, she's saying. So tell me what again. Tell me what you said again.
I was saying like if you put the x in the middle and then flip the sign.
We first of all said a while ago that when you write a compound statement, the symbols must be pointing in the same direction.
Oh, I didn't.
All right. So this, and then she's saying, I guess you're saying that, right? Okay. When you write a compound statement, you're saying this: x has to be less than 2, and at the same time, it has to be less than -2. That's what this is saying.
It's a union. Is that what that is? The union.
This is not. This makes no sense. Mathematically, this makes no sense. You're saying x is less than 2, which is what this is, and at the same time, it has to be, I'm sorry, which less than 2 means this right here.
Okay.
Is x less than 2? Is this correct? No. All right, so you can't do that. That doesn't even follow this. So remember last semester, you talked about union of two sets. The union, or an or statement. Remember that? Or means what? Union. So you could do this as well. Union. The U for the union. Okay. So here's how you write it as an interval notation, though. Okay, so how do you read this? This arrow is pointing towards what idea? Negative infinity. And remember, you always go from left to right. Go from smallest to largest. So this is pointing towards negative infinity. Now remember, infinity, negative infinity, you're always going to use parentheses. Even if this was a greater than or equal to, with infinity and negative infinity, you'll still use parentheses. So this will always be a parentheses when it's attached to infinity or negative infinity. So you're going from negative infinity all the way to what number? Negative 2 with what? Parentheses, because I cannot use negative 2, right? Union, remember the union symbol, you got to use union. Union, and then I'm going to start from where? 2 to what? Positive infinity. Just like that. So there's your interval notation. All right, so basically, remember how we got this graph. We got the graph to begin with by thinking about what numbers will make this thing work. All right, and then we wrote as an inequality symbol, which is how you're going to rewrite the statements that are much more difficult than this. So let's use this idea with number 4. Absolute value of x, absolute value of 2x minus 1 is greater than or equal to, let's say, 7. Okay, that's a greater than equal to now. So greater than equal to, you got to remember that two separate inequalities. One going to the right, the other going to the what? Left. So the one going to the right is going to be what inequality statement?
2x minus 1 is greater than or equal to 7.
Yep. So I'm going to put it right here. 2x minus 1 is greater than or equal to 7. So that would be one of them. Or what's going to be the other one? Let's do it this way.
2x minus 1 is less than.
Yes, you just switch these. You just switch them. Because remember, the other one, in your mind, you see both of those visually. So the other one's pointing to the left. So that's the less than. So 2x minus 1 is less than or equal to, and then switch the symbol, the sign. Negative 7.
Does it matter which one we write in which position?
No, it doesn't matter. Like here, I put the greater than, but we tend to put we tend to put this first because graphically, it would match up.
Okay.
You see? I mean, it doesn't. This is not the graph of this, but when we graph it, this is going to be the pointing to the left, and it's going to be pointing to the what? To the right. So that's why. But it didn't matter. You could have put this first or this. It does not matter. But we tend to just put this first because it matches the graph. Yes.
Why do the inequality signs change?
Say it again. Why what?
Why do the inequality signs change?
This is greater.
What? I'm sorry. What was the question?
Why does the sign change?
Well, because tell me what. When we did this, do you understand why this was x is less than? Okay, so when you do this one, it's gonna be the same idea. It'll be less than. So this is less than. This will be what? Less than. This is greater than. This will be what? Greater than. Graphically, the graphs are two separate graphs, right? One's pointing to the right. When you think pointing to the right, you think greater than, correct? Yes or no? When you point to the right, you think greater than, correct?
Yes.
When you point to the left, you think what? Less than. So less than, greater than. They're two separate inequality symbols.
So that's because it's absolute value.
Yes, absolute value. Yes. If this was strictly an inequality, if this was, now in Math 98, you had this. 2x minus 1 is greater than or equal to 7. That's just a linear inequality, right? You would add 1 to both sides and then do what? Divide by 2. That's not this. This is absolute value. This is just a linear inequality. All right. Now let's solve each one individually. So notice I went from a absolute value inequality to how many linear inequalities? 2. I got to solve each individually. Okay, how to get x by itself? Add 1 to both parts. So I get 2x is less than or equal to negative 6. What's the next step? Divide both sides by 2, and so x is less than or equal to a negative 3. So my graph so far is going to look like this. Negative 3 with what on negative 3? Pointing which way? to the left, and doing what now? What? Shade in with an arrow. Because that's what this says, right? So remember, from this one, one's going to the left, the other one's going to the right. And that's what this is. Over here, if I solve for x, add 1 to both parts, combine like terms, I get 2x is greater than or equal to 8. Next step is to divide by 2. So x has to be bigger than or equal to what? 4. So the graph, here's 4. Bracket of parentheses. Bracket because I can use 4, right? 4 is a solution. That's what you're saying. Huh? So if you plug in 4, 2 times 4 is 8. 8 minus 1 is 7. Absolute value of 7 is 7. Is 7 bigger than or equal to 7? Yes, it's equal to. So that's why we can include. That's why there's a bracket. And then everything to the right. So there's your graph of the solutions. Interval notation. Okay, always do this one first. You got to do this one first. Negative infinity all the way to negative 3. Now, what do I put on negative infinity though? Parentheses. Negative infinity, comma, negative 3 with a bracket. Now remember, with infinity, negative infinity, you always use parentheses regardless of if there's an equal sign or not. Because it's not a negative infinity is not a number. It's a concept. It just keeps on going. It doesn't stop, right? When I go to the right, it stops at what? Negative 3. And that's a solution. So I got to use bracket here because it is a solution. Union, remember you got to use union, correct? Okay. And then what I'm going to write next? 4 to infinity. All right, so there's your interval. So 2 separate intervals. So greater than, for the most part, will look like this, unless it has no solution or an infinite number, which on the test I'm not going to do that. And then less than is going to be bounded. Bounded, look like this. Okay, let's do one more with this. Let's look at this one. All right, this is 5. All right, suppose you had this. Suppose you had 3 times the absolute value of x plus 6 is greater than, let's say, 3. Yeah, so you got to get the absolute value by itself. So don't distribute. Especially if this was a negative 3, you don't want to distribute if this was a negative 3. So to be on the safe side, just go ahead and get the absolute value by itself. Now, if you were to distribute a positive 3, it would not be incorrect. But if this were negative, you would have an issue. So to be on the safe side, get the absolute value by itself. That was the whole idea, remember? Remember when we did this one? What do I want to do? I had to subtract 3 from both sides to get the absolute value by itself. So you want the absolute value by itself. Right now it's being multiplied by what? 3. So I got to do what to both sides? Divide by 3. So I'm dividing by 3, correct? 3 divided by 3 is 1. 1 times the absolute value of x plus 6 is the absolute value of x plus 6 is greater than 1. All right, now from there we're going to rewrite it without the absolute value bars. So if I rewrite it without the absolute value bars, and remember that's an OR statement. So what's going to go here on the right? X plus 6 is greater than 1. Now remember, a common mistake people make is that they stop here and solve this one, but you're forgetting about the other one, right? So be careful. So then x plus 6 also has to be what? Less than a negative 1. And then there you go. You just solve each one. So subtract 6 from both sides. I get x is less than negative 7. Subtract 6 from both sides. Combine like terms. I get x is greater than negative 5. So you put that on a number line. So you graph it. And remember, always make sure you go from smallest to largest. So negative 7 is smaller than a negative 5, correct? So on the number line, you agree that this is a true statement. Is that correct? People, you're in college algebra now. Okay. All right. At negative 7, parentheses the bracket. Going which way? To the left. And I do a what? Arrow. Over here, negative 5, parentheses a bracket. Yeah, because there's no equal sign, right? If there was an equal sign here, then you'd use what? Bracket. Pointing to the right, and then draw your arrow like this. Okay. And so interval notation. Union, parentheses, and then union. Yeah. Okay, now one more, and then we're going to go to systems. Okay, what? Okay, what if I had a negative 2 times the absolute value of 2x minus 1 is greater than, let's say, 6. Divide by negative 2. Very good. Yes, correct. So remember, you went, for those of you that weren't here last class period, I asked you to look at the videos. And one of the things we talked about was that, and you did this in Math 98, but remember when you multiply or divide in both sides of an inequality by a negative number, what must you do? Reverse the inequality symbol. So when I divide both sides by negative 2, sometimes if you need to, just circle this to remind yourself you have to do what to this? You must reverse the symbol. Okay. Only if you multiply or divide by a negative number, which I'm doing here. So negative 2 divided by negative 2 is a what? 1. 1 times the absolute value of this is the absolute value of this, correct? So that's what you have on the right. Is what? Less than what? Negative 3. All right. Well, I didn't want to do it like this. I'm gonna change it. I'm sorry. And here's why. The absolute value. This right here is always going to be what? What kind of number? Positive or 0. Is a positive or 0 ever going to be less than negative? No. So here you would automatically say no solution. Right. Now on a test, I wouldn't ask that. On a final, they would. You may see it on my math lab. So I guess I can just go ahead and leave like this and then redo what I wanted. So this is always going to be what kind of number? Positive. Now you understand that's always going to be positive, right? Because that's absolute value of a number. So whatever I plug into this is going to be a number, whether positive or negative. But the absolute value of it is going to be what? Positive. So this is positive. But is it ever negative? No. You understand it's always going to be positive, or it could be what? 0. And here's why it can be 0. What if x is a half? What's 2 times 1/2? What's 1 minus 1? What's absolute value of 0? 0. So positive or 0. But regardless, is a positive number or 0 going to be less than a negative number? No. So this right here is never negative. So you would say x equal blank. You would say no solution. Or you could put what symbol? We've set. Now, again, I'm not going to put one of these on a worksheet, but if I did, and I give you the graph, what would you put on that graph? Nothing. Leave it blank. So some students get confused. Oh, there's a graph there, so probably want something. No, leave it blank. All right, so let me go ahead and do one that I wanted to do. So negative 3, let's say. Let's change it. Negative 3 is negative 3 times the absolute value of x minus 4 is greater than, let's say, negative 9. It's greater than negative 9. Okay, what's the next step?
How about -3?
Divide by -3. All right, but I am dividing by negative, both sides of equals by negative number, so what must I do? Just reverse the equality symbol. -3 divided by -3 is 1. 1 times this is x, the absolute value of x plus x minus 4, right? Is what? Less than 3. All right.
So now do you write it as a compound statement?
Yes, because it's a less than. Remember that? So less than, you write as a compound statement. So you got to think that interval, so it'll be bounded. It won't be that, those two arrows, for the most part, it will be bounded. Usually when you have this, it will be bounded. Okay? All right, so what are you going to write first? Okay, that's fine. -3 is what? Less than x minus 4, less than 3. So remember, less than is a compound statement. Greater than is where you write two separate inequalities. All right, all you do is get x by itself, so you're going to add 4 to all parts. And so -3 plus 4 is 1, is less than x, is less than 7. So your solutions are going to be between 1 and 7. Okay? And you can check. Let's just check a couple. And remember, you always go back to the original. Always go back to the original. -3 times the absolute value of x minus 4 is greater than -9. That was the original. So give me a number that's in here that's supposed to be a solution. 3. All right. What's 3 minus 4? All right. And then that's going to be multiplied by what? And I want that to be bigger than -9. All right, let's check. What's 3 minus 4? What's the absolute value of -1? Okay, that's 1, right? That's also being multiplied by what? And what's -3 times 1? Is -3 bigger than a -9? Yes. And see what I did? So 3 minus 4 is a -1. The absolute value of -1 is a +1. 1 times a -3 is a -3. That's what this is. And is a -3 bigger than a -9? Yes. Let's look at 6. I'm just going to do it here. What's 6 minus 4? 2. What's the absolute value of 2? 2. 2 times -3. Is -6 bigger than a -9? Yes. Give me something here that doesn't work. 0. Okay, 0 doesn't work. Let's see why. What's 0 minus 4? What's the absolute value of -4? 4 times -3. -12. Is -12 bigger than a -9? No, it's less than. Right. Y'all agree -12 is less than -9, right? Okay. What was your question?
Well, it's about something. I'll wait to do that. I mean, it's about this, but it's
Go
not
ahead.
this question.
Go ahead.
Okay, so on one of the worksheets, you gave us absolute value of 2 minus 3x is less than or equal to 8.
Okay.
And so then you subtract the 2
Uh-huh.
from each side.
And then divide both sides by negative, and then you switch the symbol.
And then you switch the symbol?
Yep.
Okay, I just wanted to make sure I
Yeah.
did it right.
No. So her question is more like this. The absolute value of, let's say, 3 minus 7x is, I'm going to do less
Yeah, less than or equal to.
than or equal to, let's say, 9. I want to make it a little bit easier. I don't want to deal with fractions if I don't have to. Well, that's fine. We can deal with fractions. Okay, so it's a less than. The absolute value is by itself, so how are you going to rewrite it?
3 minus 7x is less than or equal to 9.
And at the same time, -9. Okay, what's the next step?
Subtract 3 from all sides.
All right. So -9 and a -3 is a -12 is less than equal to 7x is less than equal to 6. Okay, let me go ahead and rewrite this. All right. Now remember, when you write a compound statement, these have to be in the same position. I mean, the same order, right? Less than, less than. Okay. What's the next step?
Divide by -7.
But since I'm dividing by a negative number, I've got to do what? Switch these. I've got to switch these. So positive 12/7, positive 12/7, because a negative divided by negative is a positive, has to be bigger than or equal to what? X, and that has to be bigger than or equal to a negative 6/7. So positive 12/7 has to be bigger than or equal to X, has to be bigger than or equal to negative 6/7. Now remember when we did this here, we always go from smallest to largest, right? Okay. So when I graph this, now basically what I'm saying is that all my solutions are between or in this interval right here, correct? Okay. But when I draw the graph, mistake people make if they're not careful is they're going to put 12/7 and then negative 6/7. Is that correct? No. You're going to go from smallest to what? Largest. So what should be listed first? Negative 6/7 and then what? 12/7. And then at negative 6/7, what do I use? Bracket at 12/7 and then shade in. So in terms of an interval notation, you're going to say bracket negative 6/7 to 12/7 with a bracket. All right, now here's the question. You're going to have to make sure you understand that this is this. This is this, because what that says is this. X has to be bigger than or equal to what? Negative 6/7. Is that true? Yes. At the same time, it has to be also less than or equal to what? 12/7. So remember, in a previous course, when you said X is greater than negative 6/7, and at the same time it is less than 12/7. Remember, you look for the intersection of those two graphs? That's what this is in a previous course. But basically, what you need to remember is that if you rewrite this backwards, putting negative 6/7 first, this symbol becomes what? No. Yeah, because this is saying X is greater than or equal to negative 6/7, which means that negative 6/7 is the smallest. So negative 6/7 is what? Less than or equal to X, and at the same time, it's also less than or equal to what? 12/7. So people get confused with this, where the larger one is listed first and the smallest one is listed last on the other side. Just rewrite it backwards. So when you write it backwards, this is this right here.
I just want to make sure I didn't miss a step with that flip thing.
Yeah, that's what you do. So obviously there's one in the worksheet. So that's how you're going to do it. Make sure you do it just like that. Okay? All right. Okay, now let's look. Now, one of the things, okay, we're done with this part, with section 1.7. So that's the end of 1.7.